Hello friends, welcome to my YouTube channel Friends Pride. Today I am here with the topic of class 10th, chapter 10, that is light, and we are going to discuss what is reflection. So before proceeding further, I would like to request you guys to please like and subscribe my channel and also my videos. Please have a look on it, okay? If you like my video, please like it and subscribe it. So let's proceed further without taking and wasting much time. So first is, what is reflection? This is laws of reflection. So what is reflection? And this is very important, one of the important laws which is most oftenly asked in the examination. So let's discuss what is reflection say. It says that the angle of incidence is equal to the angle of reflection. So as in the picture we can see that this is the I, capital I, this is the incident ray. This is incident ray I, and here it is R, that is reflected ray. So this ray that is coming, this ray is called incident ray, and this ray which is leaving after reflecting back is reflected ray. Okay, and here this is the object that we see on which the light is falling and then it is reflecting back. This is the object. P is the point at which it is falling, the light is falling at the point P, and normal is perpendicular to the object. Normal is always perpendicular to the object. So we see that the first point state that the angle of incidence is equal to angle of reflection, that is angle I is equal to angle R. Now what is angle I? Question is also asked like that, ki define angle of incidence. So angle of incidence is the you can note it down that the angle of incidence is the angle between the normal and the incident ray, and angle of reflection is the angle between normal and the reflected ray. So I is equal to R, angle of I is equal to angle of R. And then second point state that incident ray, reflected ray and the normal all lie in the same plane. As we can see here at point P, they all lie in the same plane. So the light that is coming at this direction is reflecting back to this direction. Okay. So proceeding further, the next question, which is also very important, that is asked is what are spherical mirrors? Okay, so the common type of curved mirrors are called spherical mirror, which are curved are called spherical mirror. So mirrors in which reflecting surface are spherical in shape, okay, the reflecting surface are spherical in shape is known as spherical mirror. Reflecting surface of mirror can be curved inward or curved outward. The one in which is curved inward is known as concave, and the one in which it is curved outward is known as convex mirror. Okay, now proceeding further, let's see some important terminologies. Like, what is pole? The center of reflecting surface in a spherical mirror is pole. Like here it is shown pole, this is the point, this point is pole. Okay, so it is at the center of the spherical mirror and it is represented by letter capital P. Then comes center of curvature. So what is center of curvature? The center of curvature is the surface in spherical mirror which is at the center is known as center of curvature. Now center of curvature in convex mirror lies behind the mirror, and in concave mirror it lies in front of the mirror. Okay, then comes R. R is half of the radius of curvature. R is half of the center of curvature. Okay, then comes principal axis. Principal axis is the straight line passing through the pole and center of the curvature in a spherical mirror. This is principal axis. Then comes principal focus. The reflected ray appears to come from a point on principal axis. This is known as principal focus. Okay, the reflected rays appears to come from a point on a principal axis, which is known as principal focus. Then what is focal length? The distance between the pole and principal focus in a spherical mirror is known as focal length, which is denoted by letter small f. Then what is aperture? The diameter of reflecting surface is defined as aperture. This is the diameter of the reflecting surface, so it is called aperture. Now very important point, that the radius of curvature is twice the focal length. R is equal to 2f. It is very important, please remind this. Okay, then proceeding further, rules of the image form. This is the most common and very simple rule, just you need to understand it. The first rule states that a ray parallel to the principal axis, like here, this is the principal axis. So the ray parallel to the principal axis should pass through the focus. Okay, should pass through the focus after reflection in case of concave mirror, or appear to diverge in case of convex mirror. Like here we can see it's coming in this way and it's getting reflected in this way from the center of focus for concave mirror. This is concave mirror. Now for convex mirror, it is again coming parallel to the principal axis in this way. Incident ray is coming and it is reflecting in this way, but again when we appear to diverge it, it is coming to the f. Okay, so this is the first rule. Then second, a ray passing through the focus of concave mirror or directed toward the focus in case of convex mirror should appear parallel to the principal axis after reflection. So when just opposite of the first point, it was in the first previous point, it was that the incident ray was parallel to the principal axis. Here the reflected ray is parallel to the principal axis, just the opposite of that. Okay, now third, a ray which is passing through the center of curvature in a concave mirror or directed in case of convex mirror should reflect along the same path. Like you can see here, the incident ray is coming in this direction, and again it is reflected from this direction. In the same way, in convex mirror also, it's coming from center of incident ray is coming in this way and again reflecting back in this way through center of curvature. This is third rule of drawing the ray diagrams in the spherical mirrors, and if you understand these three, it will be very simple for you to draw the ray diagrams in the mirror. Okay, and then a ray which is incident obliquely to principal axis or on a concave or convex mirror is also reflected obliquely. Now it is telling that when a ray points directly to the principal axis, okay, so it will also reflect in the same manner. The angle of, as we know, angle of incidence is equal to angle of reflection, so whatever the angle is here, it will be same as here. So angle of I will be angle of equal to angle of R. Now proceeding further, let us discuss some questions. Okay, let us do this fill in the blanks. The image formed by a plane mirror is always erect and virtual. Okay. is always erect and virtual. The next question is a spherical mirror whose reflecting surface is curved inward, that is faces towards the center of the sphere, is called a concave mirror. Then third is the focal length of the spherical mirror is equal to dash its radius of curvature. So as I have already told before in this, that it is half. Okay, I told that important point, that the focal length of a spherical mirror is equal to half of the radius of curvature. Okay, then speed of light is 3 into 10 to the power 8 meter per second. Writing unit is very important. Okay, then light rays always travel in a straight line. Light rays always travel in a straight line. I hope you all have liked this video. Please subscribe my channel. Thank you so much.